So we will wait for 1-2 minutes so that some of our more join today. Okay, let's continue with our session. So in the previous lecture, we will discuss regarding what we will discuss the classification of the electric field configuration and as well as the degrees of uniformity in the electric field, right? Or the factor mu, which will be defined. Okay. So in the previously we will discuss these things. Okay. Is there any confusion in the previous have presented? Those who are present there, Jones one. Is there any problem in the previous lecture? So,
No, sir.
so shall I begin for the today's lecture? Okay. So I think we will go forward, right? So in the previous lecture, what we will discuss the classification. What are the different such kind of electric field? Like there will be the two types of electric field which we'll normally see. One is a uniform field, another one is a non-uniform field. Okay, so the non-uniform field is again in the two types, right? Non-uniform field again it will divided into the two different segments. One is a weakly non-uniform field and another one is a extremely non-uniform field, right? So in the previous lecture we will discuss the thing. So we will show you how we will discuss in the previous lecture, then we will go towards today's lecture. Okay, so wait for minutes. Okay, we will share the screen. Is my screen is visible or not?
No, sir.
Okay, 1 second. Okay, so due to some network issue, we will disconnecting our session. So we will again reconnecting. So what we will discuss in the previously, we will discuss uh, the classification, uniform field and the non-uniform field. Okay, so the non-uniform field is again divided into the two different segments. One is a weakly non-uniform field and extremely non-uniform field. All right. So the today we will discuss the what will be the utilization of the dielectric properties, which I will discuss in the previously, and what will be some brief introduction of a stress console and some figures, okay, related to how the dielectric properties will be assigned and how your stress control will be described, right? Okay, so we will go towards the lectures. Okay, so we will connect with the whiteboard session. Okay, wait for a minute, we will connecting. I think today we have a issue, network issue, so that's why it will little bit slow. Okay, so we will present now. So my now my screen is visible or not?
Yes, sir, visible.
Okay, fine. Yes. Okay. So today we will discuss regarding the utilization of the dielectric properties and the various stress control methodology which will be observed in the high voltage studies, right? So in the previous lecture we will discuss the utilization of the electrical property or the dielectric property, which will be assigned as a mu. Mu is actually nothing but a factor which will be affected due to this particular dielectric property. Okay, so what is written in this particular segment of this particular utilization of the dielectric property? So the value of a mu is also represent the degrees of utilization. Okay, it should be represent as the degrees of utilization of the dielectric between the two electrodes. Suppose we are assigning the two electrodes A and B, right? So this mu will be defined as a degrees of utilization of the dielectric property between the two electrodes. Okay, so how it will this particular factor will be affected? For the higher value of the particular mu, it will represent the better utilization of the insulating property of the dielectrics. Okay, यानी कि जितना तुम्हारा फैक्टर का वैल्यू यानी कि म्यू का वैल्यू ज्यादा होगा, ठीक है, उतना you have a better insulating property of the dielectrics. Okay, so lesser the less value of this particular mu represent what? It will be the low utilization of the insulation property of the dielectrics. That means a higher value of the mu will be finding the greater insulating property of some dielectrics, right? Okay, so it compares the ideal condition of the electric field intensity. Obviously, it should be the uniform field between the electrodes as the same distance between the D apart, which I already D is actually what? D is actually the distance between the two electrodes, either A to B or the B to A. And we will also discuss in the previous lecture if the electron which will flow from B to A. So for that cases, our utilization, our work done by the property which will be defined as a I already told you in the previous lecture that what will be your work done. U of AB is equals to integration of B to A E into dx. Okay, phi A minus phi B, where phi will be defined by the flux. Okay, so in this cases, the uniform field between the two electrodes are same distance, which will be placed as a D apart. Okay, with the existing actual minimum field intensity. Okay, so thus mu is the dimensionless quantity enables a comparison of the degrees of uniformity of the field configuration formed between the different electrodes. Okay, the table which I will show you in the previous one, in the previous lecture, which will be already show you this particular table. Okay, so this particular table will be defined what will be the value of the mu, the electrode configuration for the parallel plates, for the cylindrical surface, and for the needle plates. Okay, so for the parallel plates, mu is equals to 1. Okay, of always 1. For the cylindrical property, or for the cylindrical structures which will be weakly non-uniform field, that will be less than 0.25, and it will be extremely non-uniform. In case of an extremely non-uniform field, the electrode configuration will be like a needle to needle plates. For that cases, your factor will be very less than 0.01. Okay, so from that particular table, it should be written that table 2.1 will be gives the value of a mu of a typical field. Okay, the value of mu will be lies between 0 to 0 लेस देन म्यू लेस देन वन, यानी कि ये जो वैल्यू है फैक्टर का, म्यू फैक्टर का, that will be vary from 0 to 1, as we will see in this particular table that mu which will be always 1 when it should be in a uniform field, and if we are using the two parallel plates, okay, mu is equals to less than 0.25 if we are using the concentric cylinders, okay, which will be also known as a weakly non-uniform field class. This is actually the field classification which will be defined. Okay, and mu is very less than 0.01 if it will be in a extremely non-uniform field, and when we are using this particular plate at a needle plate. Okay, needle to needle, and point to point, that means like this. Okay, so we are using this particular two electrodes, and this needle to needle points, and electric field will be defined in such a cases, right? Okay, so right now this is over. So these things, keep remind these things always. The value of mu when you have a calculation of your problem na, so you must require the what will be the value. Sometimes it may happen your mu will be defined in the problem, so sometimes it may happen you have to remember the particular value of a mu which will be lies between the 0 to 1. Okay, so keep remind these things always. Okay, so with this particular knowledge, the value of mu for the practical field configuration, the practically mu का value जो है mu is equals to 1. ठीक है, ये practically नहीं आता है, but theoretically we will defining the value of the particular factor will be from 0 to 1, but practically it should not be goes to 1. Okay, it may have some less than 1, right? Okay, so what is written with the knowledge of the value of mu for the particular field configuration, the maximum electric field intensity of the maximum electric stage of the dielectric can easily be estimated. Mu serve as a ready reference, which is the important information for the insulation design of the equipments. However, for the determining the exact magnitude of the maximum electric stage, a different shape of electrode used in the equipments, numerical estimation techniques have to be applied. So what does it mean? Actually, for defining your factor mu, we are developing or we are producing the different properties. We are defining the different electrodes, different shape of electrodes, right? So in this particular structure, we are defining or we are describing the three different electrodes. Okay, the three different shape of electrodes. Okay, so this is the one parallel plates shape of electrodes, this is the concentric cylinder shape of electrodes, and this is the needle shape of electrodes. Okay, so here it should be written that a different shape of electrodes used in the equipments. Okay, used in the equipments for the numerical estimation techniques have to be applied for the different types of shape which we are using for calculating the mu, the value of mu. Okay, so now that is actually the utilization of the what will be the property. The property, so the dielectric property will be depends upon what the value of mu is, right? So and the value of mu will be depends upon what type of field, okay, or what shape of electrodes you are using. in the device or in the equipments. Okay, obviously it's a high voltage equipments, right? Okay, so the now we will go towards the stress control, right? So what the stress control is, in the next to next previous lecture we will discuss few little bit about the stress control. The stress control will be defining depending on the what the dielectric property of a particular electrode is or the particular equipment is. Okay, the stress of a particular device is how should I control these things, that we will discuss in this particular section. Okay, so what should be written in the first point? More the uniform in field, it should be written that more the uniform in the field, better the utilization of the dielectrics. Okay, जितना तुम्हारा यूनिफॉर्म फील्ड का यूनिफॉर्मिटी जितना तुम्हारा ज्यादा होगा, दैट मीन्स योर डायलेक्ट्रिक प्रॉपर्टी विल बी बेटर. ओके, सो जितना तुम्हारा डायलेक्ट्रिक प्रॉपर्टी ज्यादा होगा, दैट मीन्स योर वैल्यू विल बी मैक्सिमम. ओके, सो फॉर द बेटर यूटिलाइजेशन ऑफ योर इक्विपमेंट, for the better utilization of your equipment, you should have the uniform field. It should not be some, it may happen due to some fault we have a non-uniform field. Okay, so for that cases, what equipments you are using, so that they have a not very good dielectrics. Okay, so this things is very important for these cases. Okay, keep remind these things. Next point is, an ideal utilization is accomplished only when your mu is equal to 1. Okay, mu is equals to 1 जब होगा, then your ideal utilization will be takes place. Okay, your ideal utilization will be takes place when your value mu is equals to 1. Okay, mu is equals to 1, but theoretically we will show that thing, we will told that thing, but practically when we go for the practical experiment na, so for that cases mu will be never come equals to 1. Okay, so that will be actually the assumption in the theoretical purpose. Okay, so that's why it should be written that which will be not possible in the practical cases, or the in the practice when we go for the high voltage laboratory na, so for the any such kind of experiment, so for that cases the mu we will considering less than 1. The what will be the finding of the mu, the value will be near about 1. Okay, not actually 1. Okay, so now the third point is the more non-uniform field. So we will discuss the uniform field, now we will discuss the non-uniform field. More non-uniform field represent the higher electrical stress. जितना तुम्हारा नॉन यूनिफॉर्म फील्ड ज्यादा होगा, उतना तुम्हारा सर्किट में इलेक्ट्रिकल स्ट्रेस ज्यादा होगा इन द डायलेक्ट्रिक्स. इट कुड बी ओनली इन अ पर्टिकुलर लोकेशन. Okay, so insulation design is an equipment is made with a due consideration to the value of estimation maximum electric field intensity. That means what it will be written, that if by choosing the non-uniform field represent the high electric stress, so due to this high electric stress, what will be happen, the insulation design will be damaged, or insulation design of the equipment, it will be made in a such a way that your uniformity of the field will be defined, right? So for that cases you should always be use the uniform field whenever you have designing your high voltages apparatus or the high voltage equipments, right? Okay, so the fourth point is, it's possible to achieve a higher degrees of uniformity of field by giving the suitable shape and size. Yani ki shape and size is a matter. Okay, for better dielectrics. Okay, for the better dielectrics, these things will be needed. See what type of shape you are using and what type of size you are using for considering the better utilization or the better uniformity of the field. Okay, for the various electrodes in the equipment, this point is very important, right? This point now is very important point. Okay, so now this is for example. Okay, abrupt interaction of the electrodes, both anode and cathode, in the high voltage equipments leads to concentration of the electric field as a beam, resulting a tremendous enhancement of the electric state in the dielectrics. The dielectrics in the vicinity thus become highly vulnerable for the breakdown. Okay, so depending on your choice of shape and size, your dielectric properties will be depends, your interaction of the electrodes will be depends. So ये अगर तुम्हारा नहीं होगा, so what will be happen, there will be the certain breakdown. Okay, so there will be certain potential breakdown will be arise in your equipments or your high voltage equipments, right? So keep remind these things always when you have a uniform field, when you have a requirement of the uniform field, then you should have a suitable shape and size of the particular electrodes is needed for safely use of your high voltage apparatus or the high voltage equipments, right? Okay, so the next point is the electrode must be given as a suitable shape. It will be also been written in this particular points. Okay, now for the stress control in the principle, the electrodes are extended and form in a such a way that the higher field intensity. Okay, so when it will be the electrodes will be extended, so for that cases your field intensity will be higher than in the main field region, does not appear anywhere in the dielectrics. Okay, so what when the stress control will be increasing, okay, so what is happen, your field intensity will be increased. If your field intensity will be increased, so for that cases your dielectrics will be anyhow it will eliminate here, right? So now the next point, this is actually the Rogowski suggested in the 1923. It will be defining that thing. The Rogowski is a scientist who will be design these things in the 1923, a shape by which the electrode could be extended, which will be known as a Rogowski's profile, which will be shown in the figure 4.1. I will show you in the next this one. Okay, so there will be the two profile. Okay, one is a Baroda profile. Okay, Baroda profile. Another one is a Rogowski profile. Okay, these two profile will be applied for any such kind of dielectric property of a various high voltage equipments. Okay, so these two profiles will be very much important for these cases. So there will be the two difference between these two profiles. Okay, so one will be defining by the Rogowski's profile, another one will be defining by the Borda profiles. Okay, so another shape of the electrode credited to the Borda known as a Borda profile, which will be shows in the figure 4.1b, which is actually worked out by him is an early in the 1766. That means ये तुम्हारा पहले ये जो प्रोफाइल है ये प्रोफाइल विल बी more older than your Rogowski profile. Okay, so these things will be like this. Okay, so this will be actually the figure of the equipotential and the field lines between the planes and the beam field. Okay, so the plane field will be plane and the beam field. So this is actually the profile for the border profile, and this profile is actually for the both are same, but slightly there will be some difference. So difference I will told you what the difference is in the later on. Okay, so this is actually your electrode and this will be the mid portion of this. Okay, so this will be your field current. Okay, field current which will be flow through the lines. Okay, and this phi is actually, and near about your this point it will show that your structure will be very narrow shape, right? Okay, so the phi will be your equipotential lines. Okay, so the equipotential and the field lines between the planes and the plane field, which will be defining as a Borda profile and the Rogowski profile, right? So these things will be slightly important for these cases, although it will be no, right now for the today's studies we will not defining such kind of things. Okay, so for describing or for developing such kind of high voltage equipments. Okay, so so the now um, now we will discuss about the what the these things. Okay, so we will directly go to the this will be some theoretical portion which we will show there. Okay, so what is written that in the electrode a high potential in the laboratory are given large smooth shaped dome type of bodies or shaped like a toroids to bring down the electric states of the atmospheric air. Already in the first lecture I will told you the atmospheric air is a one type of gaseous dielectrics which will be mostly used in the high voltage laboratory, right? Okay, so this is a this type of body. Okay, the electrodes. Okay, so I will show you how the electrodes will be look like. Okay, so that is actually the segmented electrodes. Okay, so complete high voltage 600 kV alternating current. Okay, so that is actually the electrodes. Okay, here actually this portion which will be shown as a electrode section. Okay, this section. Okay, this section which will be this section will be your electrodes. Okay, segmented electrode. This is the one segment supposed to be. This is the one single segments which will be assigned. Okay, so this will be the segmented electrodes. This is the one segment. This is the another segment. Okay, this is the another segment. This is the another segment. This is actually type of structures which will be shown in the laboratory, in the high voltage laboratory. Okay, this is another figure for the single metallic body. Okay, this is actually the single metallic body but the segmented electrode structures. Okay, so from this segment, this is the one segment, this is the another segment, this is the another segment. So this is the total is a one electrodes. Okay, and this one is also one segment, this is another segment, and this is, so the total 1 2 3 4 5 6 segments of the particular electrodes which will be connected parallelly with this. Okay, so this will be the single metallic body DC generator which will be connected across this particular lines. Okay, so this will be actually the structure how your high voltage will be generated in the laboratory. Okay, so here it should be written that, here it should be written that electrode have a high potential in the laboratory as given the large smooth and shaped dome, just like as a dome like of structures. Okay, it's a like a hat type of structures. Okay, this is actually the electrode, and over there that should be your hat type of structures, so that's why it should be told as a dome type of structures. Okay, so the modern trades in the such electrode design including the segmented electrodes. So modern days में segmented electrodes अभी नहीं है, ठीक है, एक single electrodes we are using in the high voltage laboratory consisting a number of small identical and the smooth discs given a large desired continuous shape as per the requirement. Okay, so there will be some brief introduction of the how this particular things will be defining. Okay, so this will be the enlarged view that is actually the structure of a particular high voltage apparatus, how it will be designing, that will be in a practical performance when you have did your practical performance in the laboratory. Then you will show how your electricity or how the high voltage apparatus will be working. Okay, so because this particular syllabus or particular subject is not been taught in a theoretical way. Okay, if you not don't see, if you don't go to the high voltage laboratory, you cannot identify what is happening or what is actually happening inside the laboratory. Okay, so some basic ideas that will be in the theoretical part, but the most of the thing will be practically you will observe in the laboratory if you are physically present. Although but in this situation it will be not been possible. Okay, so there will be the two such kind of, in the eastern region we have a two high voltage laboratory, one is in a IIT Kharagpur, another one is a Jadavpur University. Okay, we visited when we are the student. Okay, so there will be the huge laboratory, there will be various high voltage apparatus will be there, and how the high voltage will be generated, that will be shown in the particular laboratory. Okay, so if we go to the HV laboratory in the various, in the eastern region we have only two laboratories, in the IIT Kharagpur and as well as in the Jadavpur University. The Jadavpur University laboratory is very much old, like an older. Okay, but recently the IIT Kharagpur is also been developed such kind of laboratory of the high voltage using your high voltage apparatus. Okay, if you go to the laboratory now, you will see the various types of high voltage apparatus, okay, how it should be designed. Okay, it's supposed to be, it should be written in a 600 kV. Okay, so it should be generated in a 900 kV. So not only the 600 kV, not only the 900 kV, more than 600 and 900 kV also been there. Okay, so in this particular case now it should be actually, so I think we have, in the next session we will discuss, because we have a meeting today. Okay, so we will discuss in the next classes what the thing is, because the thing is that only Saurav is there or not, बाकी लोग कहाँ गया? Saurav, are you there? Saurav 1-1. I think no one is there. Okay, so then we will discuss in the next classes. Okay, what will be the remaining part of this particular session? Okay, so we will stop the session.
Thank you, sir.
Yes, yes, sure. Yes, tell me. Anybody there, or only you were there?
सर सिर्फ हम ही हैं बचे हैं.
अच्छा अच्छा, ठीक है. Okay,
ठीक है
okay.
सर.
So we will discuss in the next classes. Okay, what the remaining part
ओके
is.
सर.
Okay, so you have a huge syllabus in the high voltage engineering, right? So the thing is that you have to we will share some PDF file. We will share some PDF book version of the high voltage engineering, because you have maybe it happened that your examinations will be Koran University examination will be physical. Okay, so for that time you have examination schedule. So for that cases, I will share you a PDF version of the book, because physically it should not be possible right now due to some COVID situation. You will come to the college and collect your books. It will not possible right now. So I will share in the LMS portal what the book available book for the high voltage engineering, and we will follow this particular book for your according to your syllabus. Right?
ओके सर.
Yeah.
यस सर.
Okay. So we will. Okay. Today we will stop our session. We will discuss in the tomorrow.
ओके सर. ठीक है सर. थैंक यू.
Okay.